Thank you for being here, and we will be talking a little bit about cloud-native AI playing for the next generation mobile networks. And first of all, by the name, my name is Lingli. I work for China Mobile as a direct researcher, and it is my great honor to introduce to you Dr. Hui Deng, who is the CTO of 5G core standard, and he works for Huawei. And in this speech, I'm going to share with you the latest progress and also various proposals for a 6G, whose architecture blueprints actually featured with a cloud-native intelligent plane, which would be the main topic, and for Huawei to later introduce some of the innovations around that direction, which is also now corroborated as part of 5G Advanced already, and is expected to be serving as the basis for future explorations for next generation. And as you might already were aware, that by the middle of last year, ITUR actually published a framework for IMT 2013, which actually serves as the wish list from us for the next generation mobile network, or we all know it by the name of 6G. In particular, there are 3 new usage scenarios introduced, including integrated AI and communication as one of the new scenario, are identified and added to those we all were the typical 3 scenarios for supported already by 5G. And also 6 new capabilities, including AI-related capabilities, are identified also in that framework and added to those already specified by the key KPIs supported by 5G.
You want me to cover this part?
Yeah.
All right, so yeah, quite a lot of old friends, very familiar here. I think for this time frame, we are very critical timing for the 6G standardizations. Right next week, 3GPP is going to have the world first 6G workshop regarding service requirement hosted by 3GPP SA working group, SA1 working group. So unfortunately, I also have to fly over there. And then they are also planning for the architecture of 6G architecture workshop next year, March, hosted will be by 3GPP SA2 working group. So this is a very critical 2-time milestone for the 6G standardization work activities. And after that, so people familiar, we are starting 6G work by release 20, mostly study items, and then go to work item by release 21st. So the SA2 is responsible for the 6G architecture designing, including mostly will be, I think we can imagine one of the critical things is a 2025 of the March is quite similar to what happened in 2016. That is the release 15 for 5G started. So in my return back memory of here, so I think we are Open Network Summit has done many things by 2015. For example, you heard many open source has been announced by that timing. And then right in the end of the 2015, in 3GPP architecture designing, the proposal regarding SPA has been proposed. So this is the service-based architectures. So, so after that, December of 2015, then 2016, the release 15 get started to study the new architecture of 5G. I think this is a quite same timing. 6G is going to happen for the we are looking at, is there any relationship with open source here? Because 10 years ago, that's a strong relationship. There are open source happening before the 5G was designed. And so then service-based architecture was being proposed later, just 1 year after here, what happening. To be honest, really, I was involved in the 10 years ago, but this year I a little bit hesitated to see something happen where I influence something over there. Unfortunately, based on my current observation. So I'm working both sides. So I also go to 3PP and here trying to understand what is the best technology could be used, not only by open source, but also in the future by 6G as well. So the 3GPP, they had a consensus to follow this time frame. By 2030, 6G is going to be deployed. So before the next March, I think it is going to happen 12 months for people here to propose something, to make something happen, really influence for the 3GPP next March. So we are looking around and we are continue to follow, and this is one of the reasons we are presenting here. So and you continue. Let's see what China was proposing.
So key points from this slide is actually 3GPP is committed to the standardization of 6G, which is, whose vision has been described and published by ITUR. And as you can see from this diagram that the pre-standardization study, which focused on requirements, which will be happening as 3GPP SA1, will be starting in the middle of this year, which means that it will be happening, within months. And then SA2, which is responsible for designing and specifying the technical architecture for 6G, plans to start its technical work starting from next year. So that is what he's talking about. So if we see there are innovation solutions that could be candidate to solve what ITUR has described as part of the vision of 6G, it's time, for us to get in there and make our contributions. And as you can see that this is a very aggressive, I think, a work plan from 3GPP because it actually plans to finish the specifications in a single job, as you can see here. Okay. So I actually added these slides very lately, I think last night. I think there has been a great debate about, why do we need 6G while we are still struggling for modernized 5G? I think, from service providers' perspective, we are also trying to address that puzzle. I think perhaps we can see this question from two different perspectives. And now we have a lot of advanced technologies that actually tackles about the digital transformation from all sectors of societies. However, there are still nations, I think, around the globe that actually started to establish their basic communication infrastructure. So what we see here is that if we would like to enable the digital bridge, within a nation, it is very, essential for the government actually to enable universal broadband coverage. Otherwise, things like AI or advanced technologies, they could be of useless to people's daily life. So the key is for the communication networks, especially mobile communication networks, to address that challenge, to provide a universal, physical, high-quality broadband coverage. And that is part of the 6G's promise. As you can see, actually from the scenarios that was envisioned by ITUR, there are a lot more variety of access technologies. For example, for those connections from space, which is a very has very high potential to address those coverage issues, especially for those suburban or remote scenarios. So that is key for us to actually to enable this digital bridge, and also for the government to enable those digital welfare facilities. For example, as China Mobile has been working with different verticals inside mainland China, we would like to incorporating those digital services as part of our communication services, which could be help the digital transformation for healthcare, education, payments, etc. And from another perspective is by developing 6G as a global standardization efforts, it also helps us to avoid digital divide, because by standardization, we ensure interoperability, which could actually help us to set up diversity of supply chain from different vendors. And most importantly, we could also help with joint multi-vendor investment initiatives across different nations, because those different nations have, they are actually in different stages of digitalization. However, by applying standard technologies, we could, help them, and we could, set up global universal coverage. For example, China has been committed and actively, leading the Belt and Road Initiative, which China Mobile has also been part of that, and we have been collaborating with CSPs in southern part of Asia to do the innovations and also help them to accelerate adoptions in that region. Okay. Then for the proposed design principles for 6G, as you know that 6G is actually in the pre-standardization research phase, and there are several study groups working on this direction. And from China, China Mobile has been, publishing its vision as well. And as you can see, we have identified 6 different design principles for 6G's design. And also in the same time, Hexar, as one of the leading, I think, leading research project for European Union, also identified several design principles. And it is not, difficult for us to identify that cloudification, automation, and also simplification of the network functions are actually the common, senses on the design principles for the next generation. So that also explains, what we can see from the similarities in their architectural blueprints proposals. So firstly, from edge to core, as you can see for the resource layer, both sides considered that it will be supported in the cloud-native infrastructure. And especially, Hexar has called it out as a cloud continuum. While in China, we would call it computing power layer, which actually refers to the same thing. And secondly, at the network function layer, as you can see that new data networks or a data plane would be added and exposed its data service to the application layer. Both sides agrees on that. And thirdly, standalone management and orchestration functionalities both identified as an integral part of the management dimension, and which is actually typically the area that this community actually has been working on. And lastly, although it is consensus that 6G needs to support AI framework and security enhancements, but whether or not those 2 features would be incorporated into the network function layer or serving as the pervasive functionalities at the management domain, I think the 2 different groups have different opinions on that. And this needs to be, I think, agreed upon in the next year before the 3GPP actually kicks off the architecture specification. Okay. And a little bit more about the proposal from the European side. As you can see that they are calling out end-to-end intent-based service management automation framework, also as part of their 6G blueprint. And as I trying to interpret this diagram, I saw that this is actually another way of putting out that autonomous network would be part of 6G as well. And as you can see from the bottom layer, I think the second half of this diagram, there are 3 different layers of autonomy domains, which actually correspond to the Tianfor's autonomous network architecture. And based on that, we see that the 6G actually trying to expose those capabilities, autonomous capabilities, to third-party applications. So in other words, autonomous networks will also be incorporated for 6G's vision and blueprint from the network management domain. Another one is how network AI gets to be managed and orchestrated. This is actually a diagram that I took from an academic paper, which actually forms the basis from our proposal for the intelligent plane for 6G network architecture. As you can see that we have 3 added planes for 6G's architecture for the network function from the left side, and which needs to be managed and orchestrated by a new functionalities from the management domain, which we call it as network AI management and orchestration. And at the right side, there is a illustrative example how these different layers of AI management and orchestration functionalities actually work together to enable a third-party application that actually requires the network to be able to provide the basic AI functionalities in order to enable autonomous driving. And the latest ones, which also, trying to address, how we could incorporate generative AI, the cutting-edge technologies into the next generation mobile network design is this one. This is a latest paper, I think published earlier this year. It actually, explains, how generative AI or large language model actually can be embedded into the mobile network. As you can see that we see a cloud continuum actually here from the edge side and at the core side. And here, the edge side actually is doing, the enhancements of prompting, which actually adds the user-centric or region agnostic information and enhance the prompting and feed it into the large language model sitting at the core side to serve the terminal or the UE size personalized, applications, whatever that would be, needing or leverage these generative AI capabilities. And that is all from my side, visions and.
You haven't finished yet, so I may continue. Okay, thank you.
Yes, I think for the next section, next part, where we're also talking about what we have been already incorporating into the 5G advanced scenarios and technology suites. So incorporating network AI technologies.
Right. So I think the AI is not really a new terminology for 3GPP because it's already happened. If you look from the left to, we have been working on 5G cloud native core for very long, for more than 10 years. And after that, since then, we are also working on the 5G advanced. It's more like a AI overlay core network. So normally, I heard the presentation this morning. They are talking about how they're using AI in technical fields. So here we have three, practical implementations already happened. If you're familiar about telecom, so that's been widely used. The first one is the service intelligence. So if you know familiar, the 5G telecom operator, they're already using the AI GC for their 5G IMS services already. And it's nothing new. It's already happened. And the other one is a second to your left bottom. It's a network intelligence. So this network intelligence has been also widely used by today's lots of not only fixed but also mobile operators. They can differentiate based on NWDAF, which is defined by 3GPP network functionality. And so this kind of differentiated service that has been proposed by, the NWDAF by 3GPP already. And so the third one is the intelligent of O&M. So you saw the demo of this hyperscaler's presentation. I think this has been already done by many operators today already, but we can also see some demonstration this morning as well. So we call this more like an AI overlay call. It's more like the AI over the top of the call, right? So, but when we talk about the vision of the 6G, so we are thinking about more like AI native call, other than just overlay call over there. So this is the path we have to take step by step, other than just over the night. And so I give more one of the details. So example, how these three intelligence has been achieved by 5G advanced today by many 5G deployed telecom operators. The first one, people are familiar with multimodal communications. So they are using not only voice, speech, and text and video to generate. When people are talking, if you are familiar with data channel, which is being proposed by 3GPP release 18, so they are using this kind of AIGC kind of the content to talk for the people between the videos. So this is being deployed today, I think, in the lots of operators. It's quite sophisticated technologies. We call it first intelligence, service intelligence. The second one is about network intelligence. This is also commercially deployed at least in China. So there are 3GPP and NWDAF based network intelligence. So they can the users this kind of streaming user. They has more than tens of thousands, millions, even like 100,000 of the fans to follow their streaming real time. So the operators have to guarantee there's quality of service for their streaming. So they are demanding dedicated enterprise kind of usage of network 5G network slicing to more intelligently to analyze their traffic performance. Then they reshaping the policy through the PCC in the 3GPP 5G core, then control the traffic data in the data bars. So reshape the business model here. And then the last one is similar. You can see in this morning's presentation from hyperscaler. So this is more like the NLP based. So we are so the operators can talk into such kind of large language model based masters or assistants to improve the network performance and to guarantee the services. So these three intelligence has been AI based and also has been deployed for the mobile communication today already many different use cases. So we are thinking it's quite important for when we consider 6G the vision, because those technology AI is more like a overlay solution, AI overlay. So we are looking at in the future of the 6G, it have to be AI native solutions. So other than just on top of them. So these still decoupling solutions. So I think this is the explorations of what we happened in the past from 5G advanced. So I think you're coming back for the summary, right? So this is
that I can do it better here because I can see the slides in a much bigger frame. So to summarize, we believe that from the previous research and the industry consensus, the future 6G network will be hosted on a distributed infrastructure across the cloud continuum, and also with building and would also expose those end-to-end data and AI services or capabilities. And also, most of all, it will be managed and orchestrated following the intent-based paradigm. And what we could do from here, we are serving as the core for open source automation platform. We believe that will be the core stage to enable industry collaboration for continuous ICT technology integration, which means that we were actually integrating AI technologies from AI overlay, right, to an AI native manner, whatever that means. And also, here's the thing. The software interoperability issues will need to be resolved. Otherwise, we could not solve the standardization problem. That will not help us to either breach the digital technologies and also to re-establish the industry confidence in the coordinated development of both open source and standards. And that is all from our presentation. Thank you for your attention. So just before you leave the stage, I have a question.
Okay.
Sorry, I need to jump in here. What do you mean by AI overlay versus native AI? That is always my question. As you have just pointed out, that actually marks the difference, the differentiator, the key differentiator of how AI technologies are leveraged today for 5G and how it would be leveraged or incorporated by 6G, right?
Right. Okay. So it's more like we like to challenge each other anyway. So if you look at today's 3GPP specification, there is new network functionality like NWDAF has been defined. Many AI-based logic, they are rely on these kind of architectures. So you have to you build your today. I think mostly 3GPP core, 5G core, they are using centralized AI modeling and inference kind of the logic right around the network NWDAF. So this is more like when you have many AI logic for different purpose, for different functionality, different places, right? But you have to rely on somewhere in centralized. So that's more like you have to over those network function to top, other than right inside of each of the network functionality. If you have something in each of the AI, I'm not assuming each of, for example, in release 15, they have 22 network functionality. And then after release 18, release 17 or release 18 is a lot more than 45 network functionality. So we are not assuming every network functionality should be like AI replacement, right? So this, you put the AI inside of each of the network functionality, you call it AI native, but I assume it's not, right? So still, we have like closed loop control. I mean, for each of the special purpose of the actions, policies. So then you have an independent AI-driven kinds of like, this is what we call is AI native, okay? And my personal view, okay?
So there will be no dedicated network, a core network function like NDAF to serve as
who knows?
the
So it depends on
centralized
3GPP.
AI engine.
It depends on 3GPP consensus, the discussions over there. Anyway, I think time is up. So I really appreciate everybody here. To talk to her if you have any questions regarding 3GPP. Thank you.
Yes.
Just going back to your very last point in your final slide, the relationship between standards and open source. Would you be
The last one.
coordinated development of open source and standards? Would you like to expand a little bit more on that and how you see that coordinated development working?
Actually, I don't know which would be the best way. What I see is the lessons that we learned, along the years when we are trying to coordinate the development, for telecom cloud over the years between these two different types of communities. We are trying to actually fit our specific requirements to, for example, OpenStack and then later, Kubernetes, but it actually, did not work out effectively as we would expect it. As you can see that we also explained how standardization actually works. It works, starting from a requirement study phase, and then, goes to the architecture design, and then implementation stages. And we as service providers are very, comfortable with that way of approaching, identify requirements first, and then jointly develop the architecture, and then have our vendors, to deliver the implementation. And we doing interoperability testing, and then roll out the network. However, the open source does not, come along the way. While we are trying to feedback our requirements, I would not say that they totally ignore them, but actually they're not taking that as priorities. And so we see this, great gap between open source implementations while we would expect in our production network before we can actually deploy them. So I see that 6G might be another chance, or another round of, collaboration, period that we would think, how we could better collaborate it on this one. Especially we're trying to incorporating AI technology. And so we are adding AI into that cloud, telecom cloud parcel. So there are more factors to be considered here this time.
All right, great. Thank you for questions. Okay, so thank you, everybody. I think our session. Enjoy your lunch. Okay.
There is also a discussion forum for 6G tomorrow, so perhaps we would all be interested in participating in that discussion as well. So see if we have another group providing yet another answer or better answer to address these issues.